While we wait for other people to join, if you'd like to, tell me a little bit about your background, what you hope to learn in this workshop, and maybe do you have some experience with CAD already?
Yes, yes. Actually, I'm a graduate student and I'm having 4 years working experience with SolidWorks, AutoCAD,
Oh,
Chloe, Katia, and since like I know almost all software, designing software.
wow.
Yeah, and I'm most to with I've worked with SolidWorks
Okay.
and AutoCAD,
Ah, okay.
and then analysis software I'm using ANSYS and FEA.
Yeah, yeah. Okay.
Yeah, and currently I'm working for my report writing on I'm working with SolidWorks. I'm using SolidWorks for my designing objects.
Ah, okay.
Yeah.
Wow. Yeah. Well, then if you can handle SolidWorks and all of those, I think this will be a little bit of a cakewalk, a little bit different direction, but you
Okay.
can treat Rhino a lot like those other programs. It'll do slightly different things, and hopefully at the end you'll be able to tell me some of the pros and cons that you might see just from the outset.
Okay.
Yeah,
Okay. Maybe yeah.
yeah.
Yeah. So like actually I have not heard about this software earlier like Rhino3D. I have not ever this is a very new for me. So like how is it different from other 3D CAD software?
Right. So it's a little bit more geared towards sculpting, perhaps. Like instead of going straight from a sketch
Mm-hmm.
into the third dimension, this
Mm-hmm.
one you have the option to start with solid shapes and then manipulate them.
Okay.
So yeah, so you can start with your poly surfaces and then play with meshes at the same time, and it's a little bit different. Trying to think because yeah, yeah. I mean that's the salient point at least. That's different about this program.
Okay.
Yeah.
Got it.
So when I'm designing something that's more biomorphic
Mm-hmm.
or you know more biological shaped, a lot of curves, a lot of splines like this, I lean more towards this one than say one of the more traditional CAD softwares.
Okay. Okay. So do this software allow me to like do 2D drawings or just like 3D objects I can do?
You have the option to start with drawings. Absolutely.
Okay.
Yeah.
Okay. Okay.
Yeah. And there is a way that you can capture your steps as you go along. And so
Mm-hmm.
that way you can go through, backwards and forwards like you can in the others. Um, but I haven't really played with that feature, so I don't know how good it is.
Okay.
Uh,
Okay.
I generally just save versions and then just go back to previous files. So, but that I might start. I'm kind of new to SolidWorks, so
Mm-hmm.
I've only played with it, for a semester or so, and so um, that's that. It showed me what Rhino had not had before because I've played with Rhino for quite a
Okay.
few years. So, um, but yeah. Hmm.
Okay. And do this like software allows just a moment.
Okay.
Like do this software allow me like to print 3D print the objects? Like can I do this from the software?
Um, so it's not integrated necessarily into it as a slicer program.
Mm-hmm.
Um, that's a separate program. Yeah.
Okay.
But you can take what we make here and export
Mm-hmm.
it as an STL file, and then
Okay.
and as the Makerspace, we take those files and print them for you. So
Okay. Okay. Yeah,
yeah,
got it.
are you 3D printing already or?
Yes. My report is based on the 3D printing.
Oh, okay,
Yeah.
all right. What are you
Yeah.
going to do with it?
Yeah. So I am currently working with a bearing, like I'm going to print 3D print bearings, and then I'm going to do FE analysis of those bearings.
Oh my
Yeah,
gosh. Okay.
yeah, the torsional analysis I'm going to do, and maybe I will find the life of the bearing or many other factors related to the bearing.
Okay. Are you using the metal printer?
No, I
No.
am using the maybe we have I'm not remembering the name, but we have this FDM, 3D
Okay. Yeah.
precision modeling FDM. Just a moment, I will tell you the name of the machine that we have. And then we have even stereolithography SLA
Oh yeah. Yeah.
machine. Yeah. We have a maker board.
Oh, okay.
Yeah.
That's cool. Yeah. Yeah. Okay. I see. So that'll be interesting. I'd like to see that research as you move along.
Yeah.
Yeah.
Sure. Thank you.
Yeah. Yeah. That's exciting. And are you going to be?
Yeah.
I guess you'll be printing in ABS plastic
Yeah. ABS and PLA I'm going to
and
use.
PLA. Oh, okay.
Yes. So it will be like I'm going to use the four materials and I will do the comparison between the two machines and between the four materials.
Okay.
Yes.
And with the same settings, I guess.
Yes, with the
Okay.
same setting and the same bearing size.
Bearing size. Okay. Ah, interesting. Mm. And that's yeah. That'll be cool.
Yeah, hopefully.
Yeah. Okay. Well, I'll keep an eye out for anybody to join us, but I'll go ahead and get us started. Um,
That's all.
Excellent. All right. So, welcome to CAD Crash Rhino course. Basically, we're going to focus a little bit on. I'll present a little bit about how how CAD is used, different styles of CAD program, and kind of where Rhino fits into that, and then we'll explore a little bit of Rhino. I'm going to give you a quick tour of our Makerspace though first. So this is me. I'm Sean Scully. Been here for about 3 years now in the Makerspace in the library. I'm the full-time staff member. Um, my focus is coming out of the art realm. So I was introduced to an art cam software in a commercial jewelry setting. So I custom designed class rings and that sort of thing, and then carved them with a CNC 4-axis mill. Um, so that's kind of uh, my introduction to this realm. And then in grad school, I was introduced to Rhino as um, it was a quick workshop, like a week-long workshop for teachers. So the auto industry had paid for some high school to have a 3D printer. It was a Z Corp printer, so they could print parts and whenever they needed to, but also he could do full color 3D prints for his students and show them Rhino. And Rhino, it's a little bit of animation, it's a little bit of traditional CAD, and it's also the NURBS modeler, so it's slightly different. So this is kind of where I'm coming from. Here's where I work. This is the Makerspace. In pre-COVID time, I would say come on down and hang out. So instead, we'll give you a little bit of a virtual tour. We're really only open now for print pickup and answering questions and quick things like that. We do have a laser cutter up here at the top right. It's a Glowforge, so it's a Glowforge Pro, no, Glowforge Plus. So it'll cut through about 1/4 inch materials and engrave, and it's a very user-friendly experience. And then we have our Cricut over here on the top left. That's a vinyl cutter, and it cuts a couple other things as well. You have the 3D animation or the 3D scanner in the middle, kind of on that desk, hidden back there. And that's great for small objects, 6 inches in size. We've had people 3D scan things for that. It's really easy to use. And then at the bottom, we have all of our 3D printers. We have poly printers that primarily produce ABS plastic models, and that's FDM. Yeah, you can see it's entirely enclosed. They can print PLA, but we save all of our PLA for our Ultimaker 3 at the very far left there. So, and of course, you can look at our website for all of the details for that. So let me move you to the...
I have one question.
Yes.
So is this all available in the like Texas Tech library?
Yes. Yes. So this is, we are one place in the library that you can come. There is a 3D printer shop in the basement that's owned by ATLC. And so they're a separate service. We are much more of an educational resource. So you come in, you don't know something, we walk you through how to do things. And then if you have files that you want to print, we can print those files for you and walk you through some of that as well.
So the printing will be like free of cost, or there are some charges that we have to pay?
So there's a flat $1 fee for using the bed, and then there is 10 cents per gram for ABS prints.
Okay.
And then the Ultimaker, that's going to be 30 cents a gram for print. And then, yeah, so that's, and then if you want, we can actually print flexible plastic, so Ninja Flex. It's a TPU polyurethane, thermoplastic polyurethane, and then so that's done, and I believe that's also 30 cents a gram. So yeah, so we're super cheap.
Yeah.
And then if you are working with a research lab, then you can we can use your FOP numbers, FOPs, if they're departmental funds. We've done work for research all across campus as well. Printing anyway, yeah. And if there's issues with your models, we can help walk you through how to fix them. So that can be pretty helpful.
Okay, that's good.
And then this is our, I think you can see our page. Yes. So this is our website. So if you go to the university libraries, this is where we are in the library makerspace. We were printing a bunch of protective equipment over the break, but here you can see resources. These are all of our, we also have 3D doodler pens and another scanner, not pictured, that will scan people and rooms. So that's pretty nifty. Let's see. As far as policies, yeah, here's our policies on our cost. So we also have the vinyl cutter and laser etcher. That's the Glowforge and the Cricut. And those, yeah, you're just going to pay a project fee, and you're going to bring in your own materials for those. So it's a little bit different. Yeah, with the 3D printers, we supply all of our own materials, so that way we know what's going through our printers. Yeah. Okay, so let's get back to this. So, what can you make? You can make anything, nothing that looks like weapons or trademarked objects. We follow the student code of conduct. It's pretty standard. All right, so what is CAD? Computer-aided drafting, computer-aided design. You go through all the dimensions until you get to the third one, right? Like that's the idea. So it's a little bit different than, say, the vector graphics files, scalable vector graphics, but it does use those potentially. So here we have, the old style AutoCAD. We have a little bit more specialized CAD programs, and then we have more NURBS modelers, which is good for animation, organic modeling, more intuitive interfaces sometimes. So here we have our industrial design. We have like Inventor. We have 123D, I guess, is gone, but Fusion 360 is still available. SolidWorks, of course, you're familiar with SolidWorks. And then there's FreeCAD, which is a little bit more intense because it's kind of bare bones doing all the things that usually happen in the background. So all the math you get to see and participate in. But these are generally the outputs you're going for with these. You have your drawings, you have your sketches that you start with, and then those you bring out into your third dimension here. Versus say more specialized CAD programs, things for interior design, like Revit, things like KitCAD or KiCad, where you lay out circuit boards. Tinkercad is basically, it's a browser-based modeling program that's done basically in JavaScript. And that is going to be a very simplified version. It's going to be just solid objects that you interact, you add and subtract from each other. You can also play with the code in the background and manipulate them, but it's more geared towards kids, and it's much really quick things. But it does produce files that you can 3D print or laser cut rather easily. So here's your picture of what Tinkercad looks like. It was bought by Autodesk, so it'll become more and more of the interface is becoming familiar to people who are already familiar with Autodesk.
Yeah, I worked with the Tinkercad actually. I have taken their like online courses on Coursera, like 3D printing revolution. So I
Oh,
worked during that time on Tinkercad.
oh, cool. Yeah, yeah. Did you like it? I mean, after
Yeah, it's pretty easy, I felt.
it's super easy. Yeah,
Yeah,
yeah.
it's easy.
So if you need to get in and do something really quick and then get out, that's what I like
Yes,
to use it for.
yes,
Yeah,
yes.
yeah. We had a student who went through and designed her entire engagement ring in Tinkercad, and it was a monstrosity that kept crashing on her. It was pretty intense.
Yeah, that's great.
Yeah. Um, so here we come to NURBS modelers. So this is all based on splines, um, which is a very specific math term. But you have your Blender, you have your Maya, you have your IAM, and then you have Rhino. And you can see the industries that Rhino is really aiming for. I've always encountered in basically every architecture program, and then some commercial jewelers have something called Matrix that they put on top of Rhino that has all the presets for gems and generating all that stuff. They're slowly figuring out the generative modeling and parametric modeling. So that's growing in their newer iterations. So if you want to build something, generate an entire building, based on these elements, then that's really what it's one of its strong things that the architecture people use it for.
Okay, okay.
Yeah. So talk a little bit about, what are points. So, as you're graphing things in 3D space, that's little points, little one-dimensional area objects, and then you connect those two and you get lines, and then you use these points in order to kind of guide a line, and that's your parametric curve, right? There's a lot more math involved, obviously, and that's why I gave you the links into that. So then you have poly surfaces that you're going to build, and then those you eventually convert into mesh in order to actually print them. It's a different math, basically. You go from ideal to something that's going to be an approximation. So you have your points, your vertices where you hope things are going to be, and then you connect those into edges, and you hope that the edges meet, and then those edges create faces, and the faces become polygons. So, and hopefully everything starts connecting, right? So you're building in Rhino, you're going to be building with the surface, and then you're going to connect that into poly surface, and hopefully you're going to have that closed and watertight before you move into your mesh. So with Rhino, you have a little bit more control over these things, which is good and bad. You can really break things, but I noticed with other programs, they just keep a lot of that behind the scenes. So sometimes some of the issues that can occur are faces wind up having their normal pointing in the wrong direction. So just little math things that you have to resolve. Um, and that's why they have in Autodesk, they have NetFab, which it basically wraps around what it thinks the model is and gives you a closed watertight object and resolves some of the issues that can arise as you're building faces on top of faces, especially in the more advanced CAD programs. So yeah. So eventually we'll move to mesh, when we have a model that we like. So yeah, so you have your lines, your points, and there's basically your sketch, and then you can move that into your surfaces that hopefully are connected enough to make a solid, and then you can use that for your drawings and renderings or your 3D prints. So yeah, so you're playing with your 3D CAD model, you export into your STL. Let's see, do I define it? Yeah, surface tessellation language file. So you're tessellating it, turning it into triangles or polygons, and then that is what you can use for 3D printing and slicing, right? And that's what determines this. So in some programs like Fusion 360, they're starting to combine these first three steps where you actually can go straight from 3D model to STL into slicing and printing to interface with your printer. But not many other people are doing that since everybody has different printers and different things going on. So usually you move it into something like Cura, or we use Kiss Slicer here. So, and then there's a lot of little factors you can play with on those. All right. Yeah, and so the primary file type that Rhino uses is 3DM. It's kind of their own file extension, but you can bring in other things. Like you can now bring in SVGs, and you can bring in DWGs, OBJs, everything. Now, when you bring in a file, it's going to be a little bit limited as what you can do with it. As you've seen in maybe some Autodesk programs or even SolidWorks, like you can only do so much with some of those. But there are little things in Rhino where you can convert things back into poly surfaces and that sort of thing. So, all right. So, if you were to follow along, this is how you could install or get access to Rhino. We have on the third floor of the library, there's a 3D animation lab. We have lots of computers in there that already have this installed. All the architecture computer labs have this. And then landscape architecture also has moved partly to Rhino as well.
Okay.
But if you want to do it at home, this is there's some system requirements are there. You can get away with a lot with Rhino. As you get more complex in your modeling and as you convert things maybe into a mesh, there's some calculations that happen. And that at that stage, it might be better to go to a little bit better computer, take your file with you and convert it somewhere on another system perhaps. But it'll do most of what you want to do on most systems. If you're a Mac, I think there's even a Mac version now that's actually pretty decent. So that's possible, but it is generally a 90-day evaluation version. I think it's about $400 or so to buy it, but I'm not entirely sure on that. And they used to have student prices, but I haven't looked at that in a while. So I've known some people who have installed a 90-day and then uninstalled it and then reinstalled it. So that's possible apparently, but yeah. Cool. And then we are here to help. So You can feel free to, we can do like a one-on-one Zoom, things like that. There's also in our databases, there's something called O'Reilly. And so if you go to the, I might as well go do that. So if you go to the library website, then you can go to databases, A to Z. And then they keep changing the interface here, but let's see, search for O'Reilly, and then you click online access. And then what you do is you sign in with your email, your TTU email preferably. And when you go to click password, it should go ahead and sign on, single sign on. And so it goes through the tech system, especially if you're on campus. It might be a little weird off campus. And then to negotiate this, it's pretty rough interface. So I recommend searching for Rhino or SolidWorks or whatever you're playing with. There's a lot of textbooks and a lot of video walkthroughs here that you can really dig into. Since we don't have Linda anymore, this is our substitute for that, basically.
Okay.
Yeah. All right. Let's see. Okay. Yeah, and then other resources. There's always YouTube, as with everything else. And I think especially when you're 3D printing, specifically, I don't know as far as a Rhino community out there yet, but I know the Rhino3D website has good tutorials. But as far as a Discord goes for just 3D printing and for figuring out some of the stuff, Adafruit is pretty good. It's a company out of New York, but that's more specifically for 3D printing parts, questions and stuff. Okay, so now let's go to now I'll open up Rhino. So let's see. It's doing it while I'm asking it to screen share. So okay. So when you first open your Rhino, you'll see it'll actually have a dialog box and it'll say what kind of template of file do you want to open. I generally go with the millimeters and small objects because you can always make this bigger. And for me, 3D printing is all small stuff, so I always just stick with millimeters. Yeah. So one of the things I like to do in Rhino first, as I first walk in, is everything in here is really determined by where 0 is. That's the easiest way to kind of navigate around your objects and everything. So, and it's similar to say SolidWorks or Autodesk, that sort of stuff. So here you have your top view. These are 4 different viewports, and everything's customizable, but you zoom in and you zoom out with your scroll on your mouse in each one. And then you can right click drag, and that drags things around. So in your perspective view, you can see it really goes crazy. And let's say you only want to see one view, you can double click on the name of that view, and that'll enlarge it so you can see what you're doing. For me, I like to sketch basically in my top view for most things. Sometimes I'll move to the front, but everyone kind of figures out their own way of doing it. To ensure that everything stays at 0, the fastest way I've found is to create a keyboard shortcut. So I'm going to go up to options. So if you see here this yellow gear, I'll click on the yellow gear. And this is where you can control a lot of stuff, right? So we have our grid. So if 100 millimeters is not enough, we can play with that. We can turn on grid lines, grid axes. I go down here to keyboard, and
Mm-hmm.
for F4, I'm not really using it for anything else, so I added this. I typed in 0, 0, 0. And that's our X, Y, and Z there. So anytime I hit F4 now, it'll just automatically type that into the command prompt at the very top of your page up here. And I'll click OK. And so now, let's say I go over here to polyline, and I'll just start drawing a line. So if I just start drawing, you can see it's doing weird things. So it looks right now like ortho is on. So I'm going to go down here at the bottom, and you see that ortho, so orthogonal, so only in 90-degree increments is selected. So now I can turn that off. And now I'll have free movement. Let's say I know how long I want this line to be. Up here at the top, I can say, let's say 34. And I hit enter. And now you can see it's always going to be 34. And I just have to decide which direction it's going to go. Where's the next point going to be? Right. Let's see. Let me make sure. Oops. We had somebody in the waiting room. So, all right. I'm back. So we know that it's 34 there. And then I can just click. And right now I have OSNAP on. So that means that it's going to find all of these little control areas here. So it'll find the end of the line. It'll find near the line. It'll find the mid part of the line. It'll find the quadrant of it. Maybe, if you were to divide it into 4. So that'll close that. And now I have a closed polyline, right? Multiple lines, poly, and then it's closed. So if I look at it in my perspective view, I can see that it has some angle to it, which is pretty cool. Maybe I don't want that. Maybe I go ahead and click 1 and drag it. I'm going to turn on grid snap so I can go to the grid. And so playing around with using these viewports and then making sure you're doing what you want to be doing in your perspective view is really the key. So using that right mouse button, click and drag can really be helpful.
So I have one quick question.
Yes.
Now we do drawing on the top plane, and now we are changing that same drawing in perspective plane. So can we do we can draw in one plane and we can change the same drawing in another plane?
Change the drawing in another plane.
Yeah.
So I made the drawing in the top, right?
Yes.
And then I can go into the front and I can modify it from the front, right?
Yeah. Okay. So you can do that, right?
Yes, yeah. It's all the
Okay.
same object. They don't separate out the objects.
Okay. Okay.
Yeah. So
Yeah.
the viewports, yeah, they're not set sketches. Everything's kind
Mhm.
of jumbled in the same spot.
Okay. Okay.
So it's kind of all at once. Yeah. Yeah, because that frustrated me with some of the moving from this to, Fusion 360 or SolidWorks. It's like the sketch is a very separate thing, and in this, it all kind of stays in the same spot. So when I take this, I can then go to the solid menu and extrude planar curve because it's on a plane. So I can just extrude that curve into 3 dimensions. And so you can see all the different things I can control and direction, whether it's extruding in both sides, both directions, whether or not it's solid when I do extrude it. So I don't, it'll automatically create those faces on either side. Um, whether or not I delete that original line that I'm extruding, all of those things you can control. So maybe I turn off both sides and I only extrude one direction. Now let's say I want to go maybe 2.5 millimeters. So I type 2.5, hit enter, and now you can see it's 2.5 millimeters tall. And you can kind of see what's going on there. So one thing that might be helpful as far as seeing what you're actually doing is to use these drop-down menus. So you have different settings for each of these viewports. So now the perspective is going to be shaded. So I'll see where these faces are as if there was a light source and all of those sorts of things. So, but at the same time, I still see all these vectors. And these can be handy. So now it's rendered. So I see it more as like an object, a solid object with material properties, kind of floating in space. I can see it ghosted, so you can kind of see slightly through the object, which as you get more complex can get really confusing. But you can see I can select through the object to what I want to select. So whenever you're clicking in some place where there's multiple objects that you could be selecting, it's going to give you this selection menu. And that's just a regular left click to get there. And so I want to select the curve. So now I've selected the curve. There we go. So let's see. So now what we can do is I can play with the transform a little bit. So now we've made a shape. I'm going to go ahead and scale it. You can scale it in different directions. So you can say scale it only in two directions. So I'm going to set where the center of the scale is going to be and then where the edge of it will be. And that can determine how fast it scales up. So all these things you can kind of control. You know, let's say I can control Z, control Z. If you want to record your history, you know, if you're used to that sort of thing, that's where this is where the button is down here. So I'm not entirely sure how that works. Okay, so I'll turn it on, we'll see. So if I wanted to double this, I could simply, let's say I want to double it in length and width, but not in the height, right? Since it is still in those planes, I can go to transform, I can scale 2D, and I have grid snap on, so it is snapping to the grid, and I can click 1 millimeter, take that to 2 millimeters, and now I've doubled its size. So, you know, so it does the proportional thing there, which can be really handy as you're playing around. There's other tools in here, say mirror. I can just select an object, any of these objects, solids or surfaces. Let's see, so I can just create a surface, extrude curve straight. Now you'll notice I'm in surface and not in solid. So when I'm in surface, it's going to only go wherever the extrusion is. So if I hold shift and use the right mouse button to click and drag, that moves the work plane around. And then zooming in and out is your scroll, so that can be really helpful. So now you see this is just surfaces. It's not a closed object. So to close this object, I would probably go to solid, and then I want it to be solid, so I'll cap the planar holes. And then it should create a solid object like that. Now, because these are solids, it's hard to move things around in perspective. You don't really see what's going on. So I usually aim for things with these guys using the different viewports. Now you can also transform rotate. So let's say I'm going to turn off grid snap and ortho here. Okay, so I clicked somewhere else. I unselected my command of rotate. So now I'll just right click and it redoes it. It redoes the command that you were doing before. So I can rotate that one. You have your reference. So let's see what it did. There we go. Cool. Okay, so let's see here. Now what we can do is, let's say we want to join these. We can take the Boolean solid and union them. Well, let's union one set and then subtract the other. So what you do with your solid objects, because they're closed objects, we know that they're closed, then this will work nicely. If they're not closed, then the Boolean can do really strange things. So we're going to go ahead and union these, and you see how that ghost on the inside changed. Now with these, I want to take this and I want to subtract this shape from those. So I'll do a solid difference, select the poly surface to subtract, and hit enter. And to be able to see that a little bit better, I'm going to go shaded and not selected. So that's pretty cool. But, you know, so holes and everything, so that's the basic modeling with, you know, regular shapes. But let's go ahead and make a duck. So we'll go ahead and make something that's a little bit more biomorphic, which is a real strong suit of this program specifically. So I'm going to move this out of the way. And we're going to play with a sphere. So if you right click on here, you'll get all of the different options of solids that are already made. You just have to determine what those dimensions are. So I'm going to click sphere. And now I'm going to make sure that's in center. So I'm going to hit F4. And then I'm going to turn ortho on. Now, whenever you start a sphere specifically, it is just a surface that runs from one edge to another edge all the way around. So there's technically a seam when you make it. So if you're going to manipulate this sphere, you don't really want to cut any part of the sphere or play with parts of the sphere that are the seam. So I'm going to move from the center to the right, because I'm only going to play mostly with the left-hand side. So if that makes sense. Let's see. Okay, good. Cool. There we go. Got a little too close. Okay, so one thing that I want to do. So right now it's wanting me to make another sphere, but I'm going to go ahead and hit escape. And escape gets me out of whatever command was happening at that time. It's always a good idea to take a look at what's happening in the command. There's different tools have different steps that you have to go through, and that all gets walked through. You get walked through all of those steps up here at the top. And you see all the things that you've done as you scroll through this log, basically. And usually you only get to see what you've done since you've opened the file. But I'm thinking with the record history, that might get extended. So they might save this as a file, perhaps, or do something similar to maybe Fusion 360 where you get to walk through backwards through. But let's see. Okay, so what I need to do right now is this is a pretty simple sphere, so there's not going to be a lot of control points that I can play with. And what I want to do is I want to modify this to make this the body of a duck. So we'll give it a tail, basically. So I'm going to go up to Edit and then Rebuild. And so what that does is, adds lines of longitude and latitude. I don't really mess with these setups here. That usually gives me enough control points to play with. So I'll click OK. And now I'm going to turn on my control points. So I'll go to Edit, so Control Points, On. So that's going to be F10. And there you see all of these crazy control points you can play with. So I'm going to go to Front, and I'm going to maybe do a selection box with your left mouse click and drag. And I'm going to make sure ortho's on, so it only goes in one direction. When you're playing with these control points, you can really deform the shapes and cause errors, basically. As you saw with the spline in the PowerPoint, these lines are going to be outside your surface, right? So they're not really they're going to be guidelines for where the object actually is. And everything's going to be wind up being approximations because this is all, a perfect sphere, right? So no such thing. So, I'm going to go ahead and flatten this a little bit, select sections. And you'll notice when I do a big selection box from the front that it's actually selecting that whole section there. So everything from that vantage point gets selected. Versus if I just click on one of these control points, there's only really two control points that it's asking me what I want to move. So you have to kind of watch out about that. That's why I like to do the, modify it from one side and then maybe modify it from another side. So now I'll grab some control points on the top and I'll give it a little bit of a tail here. So now what I'll do is I'll put some of those back. And then we can really play with some of these. So you can see it's got a heck of a tail there. So that's good. Very important. I'm going to go ahead and give it a little bit of a flatter belly there so it'll float a little better. Okay, so now we have our body of our duck generally made. So now what I'll do is I will make the head. So I'm going to go ahead and hit escape, and that turns off our control points. You could also hit F11, I believe. And then I'm going to make a new sphere. So let me go ahead and turn grid snap back on just because. And we'll make this one a little bit smaller. Now you see it from the side. I'm going to move it up a little bit and back towards the body, so you can have an idea of where this is going to be. Then what we want to do is go ahead and rebuild it and click OK. So now we can do something similar with this guy. Oh, I made a mistake. So what I did was when I built the sphere, I put the seam this way from the left to the right. And it needs to be on the other side because what we're planning to do is we're going to cut into the body here and then cut into the head and then connect it with a neck, which is pretty cool. So they wind up being surfaces that become open because we're chopping a part out of them, and then we'll blend those surfaces together. And it'll do all the math for us, basically. So now that I have the seam in the wrong spot, which is really kind of barely visible, you really have to look for it to see it. So that's why I like playing with the ortho and trying to pay attention to how I build it. Now I could just rebuild it, or I could transform, rotate, click on the object, hit enter, and then find the center of that object, the edge, and then I'm going to, ortho is on, so I can go 180 degrees rather easily. And now you see the seam is not on this side anymore. It's over on the other side. So now we can play with it. All right, so let's turn on control points again, and let's give it a bit of a beak. Quack, quack. There we go. And you can always play with these as much as you want. It's a good kind of fun little object to play with and build. Everyone's duck winds up looking very different. So, yeah. All right, so we have our duck head. We have our duck body. And move them a little bit closer together. Maybe bring this guy up a little bit. There. All right, so here we have the best view for chopping away part of it. So what we'll do is we'll create a line, a control point curve. So just like these spheres are defined by control point curves, we'll make a curve of our own instead of a straight line curve or a polyline. Here we have, I'm going to go and turn off ortho, and then I have a little bit more control. And what you want to do, hit enter, okay, is start outside your object, move into your object, and then end outside of your object. That way you know that this is a cutting line that will cut all the way through. So what it'll do is it'll see this line and just assume, since you're using this front view, that you want to remove everything along that axis. So you can see from here, then I'll go ahead and hit edit trim. Oh, nope. I'll select both of them, and then I'll hit trim, and then you can click where you want the hole to be. And then you see it's still wanting us to trim. We've already done our trim, so let's hit escape. And then you can see inside of your manipulated sphere now, the body of your duck. Now we'll do the same thing to the duck head. I suppose you don't necessarily need to use a curved line for this. You could probably get away with another shape of some sort, but this will give you a smooth edge of this surface that will interact well with the blend feature, basically. Now I'll hold shift and select each one, and then I can do edit trim or control T, select the part I want to disappear, and then hit escape. And let's take a look at what we've done. Oh goodness, look at that. All right, so to blend these, what you'll need to do is I'm going to go ahead and take these. I'll select each one of those. And sometimes you don't necessarily want to get rid of things in case you want to go backwards or in case you want to use it again. So I'm going to go ahead and hide it. So that's what this light bulb is up here in your standard tools, you can do hide. Part of the interface of Rhino is that things show up in a million different places. So they're all basically the same tools. They just show up as buttons, or they can show up here in your menus, or they can show up along the side here in other buttons. They're everywhere. So everyone kind of figures out where they want to use their objects, where they want to use their tools, and how to arrange everything. So here now what we can do is I have two surfaces now. Since they're not closed surfaces, since they're spheres, they're technically surfaces, but they're usually closed, and so that would make them a solid. Now we've made them unsolid, right? So we've made them open poly surfaces. So now we can go surface, blend surface, and we want to select one edge, and then we can select the other edge and make sure that these arrows are going the right direction. They need to be both going in the same direction, basically. So now I can hit enter, and it looks pretty rough. So what we'll do is we'll play with some of these controls. So there's different things you can do and how you want it to calculate this intervening poly surface, basically. So maybe you want a little bit more of a ridge, you want a little bit more of a curvature, play with sections, same height. I don't play with those things very much. Mostly I just play with these controls and then play with maybe what these functions are. What are the guidelines that you want it to utilize? So then I'll click OK. And now it created it, but these are each separate still. So if you were to try to export this to print it, it wouldn't quite work out. Where they meet, it might do something weird. So we'll make it one solid surface. We'll go ahead and join these surfaces. So because we have built this surface based on these, that the tolerance between those two surfaces should be basically 0. So that shouldn't give us any issues as far as errors go.
Hi, excuse me, sir.
Yes.
Just making sure, because you're recording, where do
Yes.
you really post your videos?
I will be posting them on MediaSite first, and I'll send you the link, and then we will, hopefully I'll have it on YouTube as well. So,
Okay. Okay,
yeah.
because I'm about to hump off to my other class.
Okay.
So I just want to make sure I don't, and that's where you post all your videos, right? Because that means the first CAD course.
Yes.
Okay.
Yes. Yeah. So hopefully, yeah, we'll have all of them, and then it might be a few weeks before we have subtitles, but everything should be on YouTube and MediaSite. So
Okay. Okay. Thank you very much.
you're welcome. Okay, so now I'm going to, so I joined these two into one open poly surface. So now I can go ahead and click Shift and click on the other one and right click basically, and it'll join those again. It'll do the same command over and again. So now we have one closed surface. And you'd always want to look up here at your command line and make sure that the log says that it is a closed poly surface. If it says it's open, then you know there's some part that's missing, some hole in there somewhere. That means the model will take a little bit more work before it's printable. Okay, so that's the basic idea, and let's put some eyeballs on it real quick with the same sort of process. So in this one, we'll play a little bit more with scaling and see what we can do. So I'm going to go ahead and create another sphere. I'm going to do grid snap. I'm going to do ortho. And I'm going to put my seam on the left-hand side, I think. Yes. Yeah, that seems right. Yeah, so I'll put it on the right-hand side. My right, your right. Okay. Now what I'll need to do is copy paste. So I'll select it, and you can do edit, copy paste, or I can Control C, Control V. And now I have two of them. So this one I'm going to make a little bit smaller. I'm going to scale it in 3D. So whatever I do to it, it'll do evenly in all directions. And what I'll do is I'll turn off grid snap just so it's a little bit better. All right, so now I have a sphere within a sphere, which when you look at it any other way, it doesn't really look like anything. So we'll go from the top here. No, let's go from the front. So here we'll do the same thing we did with the body, and we'll chop away parts of one and other parts of the other. So I'm going to choose my control curve, turn off ortho. So this will be our eyeball on the inside and our eyelid on the outside. So I'm going to select all of them, holding shift, click, 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 and then I will do edit, trim. And so I want to remove the outside of the outside one and the inside of the inside one, which gives us this shape here. And I'll hit escape so you can see it. So you can see we've chopped away different parts of each one. And now we have these two surfaces that we can then blend together in a similar fashion to what we were doing before. So let's go ahead and do that. So let's go to surface, blend surface, first edge, second edge. All the arrows are pointed in the right direction. Hit enter. And then we'll play with these a little bit. Maybe play with curvature. You can adjust your eyeball however you like. Click OK. And now we have three surfaces. So we got to join them all together. So let's select all, Control J for join. And now they're one solid mesh. Now to put the eyeball up on the head, which hopefully is where it's at, let's go ahead and go to our right view. And then from the top, now if you ever get lost, one really helpful thing is this 4 viewports. So if you double click on this button, it'll bring you to the center for each of the viewports. So if you get lost, especially in one of the viewports, that can be really helpful. All right, so what we'll do is we'll move this around. I'm going to go and rotate it so he's a little bit wall-eyed. And then to make sure that, you can see from the top that the 0 for the X or the Y or whichever axis you decide this is right through the center of this model, right? So we can go ahead and use it in order to mirror the eyeball on the other side while making sure that everything is centered on that body. So I'm going to go to transform and mirror. Now I can hit F4. And I want to go ahead and turn on ortho down here. And now we've got our duck with eyeballs. So you can see everything is still separate. So what we'll need to do is we'll need to Boolean everything. So we can select all of them if we wanted to. Sometimes it's safer to only, if they're really complex, to only do 2 objects at a time. Sometimes the guesstimations can get pretty, can produce errors, but usually it's pretty good. So here we'll do solid, union, and now we have our complete model. and it's a solid, which is very cool. So if you're ready to print your duck, then you would go to File. So I've selected him or her, or it, or they, and then I will export selected in your file menu. So here, hopefully you've saved. I have not saved. Always a good idea. But what I'll do here is I will save as an STL. So I get to go all the way down here. Luckily, they're in alphabetical order now. So STL. And then I can say duck, right? Now, when you save STLs and export files for 3D printing especially, you don't want them to be too big. And so you definitely want them to save small. And you don't really need all the extra stuff on it. You only need the geometry, right? So only save geometry. I remove textures and I remove the plugin data. I don't need any of those things for just an STL that's going to be printed. So I can click save. And of course, you can play with the guesstimations, right? So if you need super accuracy, then maybe you go with an extra decimal point, or if you want to round out a lot of it and you know how much you want to round it out, then you could simply reduce this to maybe 0.2 or 0.1, especially with extremely complicated models that are maybe rather large. Then this becomes, losing a millimeter or a fraction of a millimeter isn't as big a deal. Generally, I leave it as is. Right now, it's a 5 megabyte file, which is pretty good, pretty big. You always want to make sure export open objects is off. You want it to double check and tell you this object is printable, this object is not. So I go ahead and click OK. So if that was selected and it was, okay, so as it is now, it'll give me a warning if this object has problems. When I was doing the Boolean union sometimes, or doing the cuts, sometimes it can create little micro gaps that are the gaps between what you want and the ideal math. There were things rounded off wrong. It can happen. So there's a couple ways to fix those things, and that would be in your Analyze Edge tools. So I can show edges on this object, and I can show this is all the different edges. So unlike maybe more geometric shape, where this face obviously meets this face, here your edges are going to be a little bit different. So you can see where all the seams are in these objects, as well as where they maybe connect. And those are termed definite edges. And if they're non-manifold, that means maybe they're on top of each other or they have some sort of errors involved. Naked edges are generally edges that are really close to being connecting, two surfaces that are almost touching, but maybe it's a millionth or a tenth of a millionth of a millimeter off in spots. So it takes that seriously. Those are all issues that can arise as you play with these more biomorphic forms and chop things and stretch them out. Because what I can do now, if I wanted to, is I can treat this like a regular object. I can copy and paste and make multiples. If I were to scale it down, maybe 3D, I can make little ducklings. Maybe I want to make a lot of little ducklings. So I could transform and array along a curve. So you can see there's a lot of transform options here that can be really handy when, okay, so let's say I want to make a lot of these ducks, but I want them in this sort of orientation along this path curve. So I want there to be 15 ducks, or I want them to be this far apart. I want them to rotate, or I don't want them to rotate. All of those sorts of things. A lot of great tools to play with. and it's loosey-goosey enough that you can play with it, and the art people get a kick out of it, but you can get super precise with how things move, or what coordinates you want to set everything to, all of those sorts of things. So in similar fashion, let's see, I could take this, maybe I want to rotate this, maybe like a revolve, so I can do surface, revolve, start a revolve axis, and then 360, from 0 to 360, hit enter, and you can make shapes like that. In the past, in the last 2 days, there was a part that needed particular, I don't know if you can see that, and I used this tool to make this, right? And it's just a matter of, okay, so I know what these dimensions are, and then I bring all that through a center axis, and then I can subtract out, the right shape for that and the right shape for this, maybe. Yeah. Yeah, so a lot of the same sort of modeling that you would do in other programs. But at the same time, I could take this shape, maybe I cap it, so now it's a solid, and then I can transform, and maybe I want to bend it. So I'll click here and turn off ortho, turn off that. And I can do some wild deformations of it. I take one of these. Maybe I take this one, and maybe I want to twist it. So twist. And I don't know if you can hear my computer really working hard, but all the calculations of what it takes to do that. You can see it has to basically recalculate everything. So it can get really complicated. Yeah. Is there something that you would like to learn? This is kind of where I start everyone, and then if they have something in particular that they use in other programs, maybe I can explore like the Rhino version of it, perhaps.
Yeah. Just I have one question before that. Like now you twisted the big duck, but it is not going to affect the array that we have done. Like it will not change the those parts, right?
Oh, right. So everything that has built that duck, it's gone. It doesn't, like, that's why whenever I make something, if I'm going to do a big change like this, I'm going to make a copy of it somewhere else, and before I do that, so that way I can walk backwards from it. But once you chop an object and manipulate it, it's kind of it's not really a reversible process, unfortunately.
Okay.
So it's not necessarily, what I'm showing you today is not the parametric kind of style that you can go back and change this or change that, and then the whole thing runs back through. That's through another program called Grasshopper in here. So that's more of a script that runs kind of on top of Rhino, and that's a very different program. As soon as I figure out how that works, then I can do a workshop on that specifically. but it's a very different process. That's more, you create I can show you. You create, let's say, points, and then those feed into a line or a vector. You know, I don't quite understand it entirely, but you can see that each of these little objects, then you make adjustments to those. So then you can add, scrolling, and you can add, this is this value, and then you modify that value, and everything runs into that direction. So then you would, bring in a box that's defined by these other objects, and then everything runs in that direction. So what I've done with Rhino is basically I'll make things, and then I'll make copies, and then I'll make the next step, and then I'll make copies, and then I'll make the next step, and then I'll make copies. And that way I can always go back to that last step rather than, and then, yeah, once I discovered that in the user parameters in Inventor and SolidWorks, like that was a revelation. But unfortunately, yeah, they don't necessarily do the modeling that I'm after with, that you can see the duck can do, right? So give and take. It's a weakness or a strength, right? I mean, that's.
Yes. Okay.
Yeah, so what like when I was designing that little part, I would go through here and I would say, okay, I want this dimension to be, 5.5, and then I want this one to be 2.2, and then I could modify my line to fit that. And, everyone figures out their own way to do things. Maybe you would start. And then you can modify these so that they touch. So you get the profile that you're after. Right, I mean, that's similar to what you would do elsewhere. Just kind of a roundabout way of doing it. And then that you would use to revolve around. Yeah. Now, as far as, it doesn't really have analysis as far as I can tell. Like the analysis is a little bit more about once you assign it properties, because you can assign it materials, but I've not really ventured much into that. I've done a little bit of maybe volume as far as, if I was to print this or carve this and then cast it in silver or something, I want maybe estimates on that. And so you could use something like that for this. But as far as like what SolidWorks does with stress analysis or anything, that's a whole nother add-on that I think is available. You'd have to check with the Rhino website though. But yeah. Excellent. So we've got our ducks, all of them in a row.
Family of the ducks we got.
Duck, duck, and then we need our goose in here somewhere. There we go. All right. Well, that's kind of what I have for you. Let's see. Yeah, so rendering. Yeah, we can play with the rendering. Yep. So once you have an object selected, then you can start playing with mesh settings and add lights, and there's a lot of stuff. Yeah, the rendering's pretty good in here. There's a lot of little things you can play with to really go crazy with it. And of course, if your model is in different pieces, then you could assign material properties to each of those pieces, right? So, you could you would maybe split where the eyes are, and then leave them split to render it, so you can have the eyes be red or something, and then you'd have the rest of the body be chrome. The classic chrome duck. Yeah, lots of fun. Lots of different tools in here, but those are the basic tools that that's the easiest way to kind of jump into the program, I think.
Mm-hmm.
Yeah. All right. Well, that's what I have for you. If you have me at least till 6:45, they close the building at 7. So,
Okay.
so you have me for a little while longer if there's something specific you want answered, or something you want me to show you.
Like I have not installed Rhino yet, so like I would like to do practice with it, like by in my computer by itself, or maybe I will come to the library and I will use those computer which has the Rhino installed in it.
Yeah.
Yeah.
Okay.
So like it was good learning the Rhino with you. Like it was a good experience. I felt like.
Oh, good. Excellent.
And what I felt is that Rhino like do rendering very quickly, like very fast. Where SolidWorks take a lot of time to do rendering.
Oh.
Yeah.
Yeah. That's true. Yeah. I mean, I've been playing with Rhino for, since 2009 or so a long time. And I only use, certain parts of it, right? For my use. And then they keep changing versions on me, and I heard SolidWorks had a big change recently.
Okay. Yeah.
Yeah. Good. Well, I'm glad you had a good experience. We do have the CAD eval form, so on the PowerPoint or on the PDF that I sent you, there should be the link.
Okay.
If you could fill that out for me.
Yeah, sure. I will do that.
Excellent.
Do I need to do it right now?
You don't have to. You can do it later.
Okay. Okay.
Yeah.
Okay. And I wanted to ask about that the certification, like for this course, will be the separate, or like how is it going to be?
The participation.
Yeah, the certification.
Oh, certification. Okay. Yeah, we're not really a certifying course. Are you talking about the Learn at Your Library certification?
Yes.
Okay. I'm not entirely sure how that works. I will look into it, and I'll ask, and I'll send you.
Yes.
I'll send you information about it. If there might not be much to it, I don't know.
Okay.
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 Yeah, but if you need, if you have like paperwork, or you need me to email somebody to say that you showed up, just let me know.
Yeah. Sure.
Yeah.
Sure.
Yeah.
It was like it was great learning with you. Like you explained very well, I felt.
Oh, thank you. Good. I'm glad. All right. You have a good day then.
Yeah, you too. So you're going to send us like the video link?
Yes. I will send you the video link and probably another copy of the PowerPoint just to be sure.
Yeah, sure. I am having, but like I will send this CAD evaluation form to you.
Ah,
Like,
okay.
do I need to send it to you, or like it will go online?
It's all online. Yeah.
Okay,
Yeah.
okay. So I will fill it.
Yes.
Yeah, fine. Yeah.
Yes.
Bye then.
Okay. Bye.
Bye. Have a good one.
You too.